My name is Dr. Manmas. 76542517 is my number. You can subscribe there. Chem and Bio 280. Chem alone is 150 Buddha. So, directions of alkenes, or the activity of these hydrocarbons called alkenes. So, the first one we talked about, that we are going to talk about combustion, whereby we say that these alkenes now they burn in the presence of what? Of oxygen. And when they burn in the process of oxygen, they form a carbon dioxide and a water. A carbon dioxide and water. Provided that the oxygen is excess. You know that if the oxygen is not excess, it's going to form carbon monoxide. So, but this is what you need to know about them when they're burning. Again, they burn the sodium flame. Why? It's because they have a larger carbon to hydrogen ratio. Carbon to hydrogen ratio. Like chemicals or the flame like a dark flame, data flame in books, those stain it like that. So the other reaction this reaction you do it in your grade 12 or your form 5. So alkanes they react with water and form what you call an alcohol. But they are conditions towards that this should be a steam, or sometimes I like to put high temperature. You need to be the water need to be boiled. We boil it, and the high pressure, and the others is concentrated sulfuric, phosphoric acid there. So test papers they can bring these parts, then they say fill maybe they will want you to fill these conditions which are necessary for you to yield what you call an alcohol. So, but the major reaction that we're going to focus on today is electrophilic addition. So you need to understand that addition reactions is a reaction whereby a molecule join the other molecules, and majority of the time it's going to result in larger molecules. But let us understand the term an electrophile. What is an electrophile? Electrophile is a negative CP molecule. An electrophile is that molecule that is going to want is always it wants to get attracted to a negative molecule. So you know that a positively charged ion or a positively charged molecule always seeks a negative charged molecule. So that's why we say that it's a negative CP molecule. It's a molecule which seeks a negative molecule in other words. So this molecule is positive, so it always seeks a negative molecule. So sometimes these molecules are partially charged. Sometimes these molecules are partially charged. You know that a partially charged molecule is going to seek a negative molecule. So we are going to do our reactions today. The electrophilic addition reactions, we are going to do it in adding HX hydrogen and a halide, and next lesson we are going to do whereby we are adding bromine, which is X2, the halide only to alkene, this into alkene. The third lesson we are going to add this to what? To alkene. But today we are going to focus on this one only. This one only. So the reactions of hydrogen halides, which you can say it is HX, whereby we say that an alkane reacts with hydrogen bromide to form this compound which is there. So this is the compound which is formed there. So let us look at this molecule. We can see that this molecule is a symmetric molecule. Whatever, when I divide it into two like this, all parts physical are the same as parts physical. And in biology, we like to say a metacyclical line. Metacyclical line. Again, even if I divide it like this, again, the molecules which are there are the same as the molecules which are there. I will get that, but that one. So, this double bond here, it is electron rich. Is electron rich. So, we are going to react it with what? With HBR there. We are going to react it with HBR. So this it's a polar bond. It's a polar. Mind you, there's induced the polarity, but here is a polar bond. Looking at electronegativity series of Chem 101, you understand that this is partially positive, this is partially negative. So this electron rich bond, this is going to attack this partially positive side, and the bond is going to break heterolytic fission, whereby a bond is breaking and it is carrying all electrons. We talked about, when I talk about halogenation, we talked about homolytic fission. Homolytic fission say that there's a bond breaking. Example, look at here. There's a bond breaking in homolytic fission, whereby after it breaks, it shares electrons. It's going to be BR. We call it a homolytic fission. You call it a homolytic fission. So this one is a heterolytic fission or heterolytic fission. So whereby this is going to be formed. This guy is going to be formed. From here is going to be formed. So this bond is going to break like this. It is breaking. So after it breaks, the edge is going to be attracted to that bond because it's going to break like this, and this edge is attracted there, leaving this